Welcome to the Journal of Biophilic Design. Thanks for joining us on the Journal of Biophilic Design podcast today. As a reminder, you can subscribe to the Journal of Biophilic Design online. Go to journalofbiophilicdesign.com and visit Become a Member page and sign up there for free events, priority booking, networking, one-to-ones, and lots more. When we're planning our designs and mapping out the layout inside our rooms, which furniture to use, or specifying what products we want on the walls or floors, we sometimes forget that a lot of this comes wrapped in plastics, and there's a lot of debate about circular economy, life of products we specify, but we don't always talk about where the plastic that things come in is wrapped in, or where we dispose of it as well. If you think about the consignment of office chairs that you had, or the delivery of lampshades and carpets, most of these are wrapped in this sort of cling-wrapped plastic. But as designers, and especially biophilic designers who care about bringing nature into our built environment, maybe we should also think about what these products are wrapped in too. I don't know what you think, but I invite people who are listening to contact me and sort of so we can get the ball rolling on the conversation. But today I've got Hao Ding with me. He's Global Marketing Director at Total Energy Corbion. He's got a master's in Materials Science and Engineering, along with qualifications in Business Sustainability Management. He's also got lots of international experience in chemicals, polymers, plastics, biomaterials, textiles and fashion. So just to list that whole bunch. And he's also obviously highly committed to sustainability and advocates responsible business practices. So first of all, Hao, thank you so much for joining us today.
Thank you, Vanessa.
That's lovely. I mean, maybe you could start a little bit by just telling us what you do, if that's all right. You know, the company you work for and what you do, just to kind of set the scene, if that's okay.
Definitely. So, hi everyone. This is Hao speaking. So, really glad to be here. I'm work as a global marketing director for Total Energy Corbion. So, Total Energy Corbion actually is a JV between the Total Energy and Corbion. So, we are one of the leading PLA producers worldwide. And then actually, so we offer this PLA-based solutions, and then yes, we also be kind of discussion partners, and really looking forward to work with the stakeholders in the value chain, and then to really explore the possibility of use the biomaterials such like PLA to solve the current issues.
Lovely, thank you. Well, we're going to talk about this PLA that you're talking about, because I had to when I found out about it, I was like, huh? What is this? But it's completely, like you say, bio-based material. So you're gonna talk about that. But I just want to again setting the scene. I mean, there's this global plastics treaty. Can you maybe set the scene and tell us a little bit about more what it is? You know, how it covers, you know, obviously how it affects the architecture and design and construction industries, please.
Sure, of course. When you really talk about the global plastic treaty, actually, it's aimed to create a legally binding agreement to reduce the plastic pollution. So we know that, we already discussed a lot that there's many industries, which actually including architecture, design, and constructions that contribute to the plastic waste. And then if you're really thinking about, when you talk about plastic waste, the fact is that now over 400 million tons of the plastic produced every year, and majority of these plastics are fossil-based plastics. So we talk about more than 99% actually, and then 91% of these plastics are not recycled. Basically means that these 91% of plastic either landfilled or burned or just simply littered into the environment. And then also that's why you really can find plastic waste like in all kind of ecosystems, in the deep oceans, in the urban environment as well. That's part, I would say, is one of the key issues of plastic or plastic pollution. But there's another issue actually I also want to bring out is when we talk about the like greenhouse gas emission as well. So then when you talk about plastics, actually plastic industry contributes 3.4% of the world greenhouse gas emission every year, which equals about 1.8 billion tons of the greenhouse gas emission, which is really enormous. And then, yeah, that's actually basically two main issues when we talk about plastics. Yeah.
Exactly. I mean, the bio-based plastics are sort of coming to the fore. People are talking about, alternatives to plastics. What can we
Mm-hmm.
use instead? And obviously, what we're trying to do is trying to specify more natural materials. And sometimes, people are wanting to create designs or shapes, but they also want to hit the low carbon footprint as well. But they also want things that are, that at least, have an origin in
Mm-hmm.
nature. Um,
Yeah.
can you tell us a little bit about, how do bio-based plastics fit in to this?
Yeah, definitely. So I think we just talked about the two main issues about plastics. I think now it's good just to break down to see how the bioplastics like PLA can tackle these kind of issues, right?
Mm,
So basically, first, when we talk about, well, it's bio-based, the main difference is compared with the fossil-based conventional plastics, it's the feedstock. So when we talk about fossil-based plastics, actually, the starting is you pump the oil from the underground, and then you crack the oil, which really need to have a very high heat. And then you get the ethanols, you get naphthas, and then you polymerize it. Then you get polypropylene, polyethylene, which really you can find in all kind of applications. The main difference for bioplastics or like PLAs, you start from the crops like sugarcane, like a corn. Actually, when we talk about plant or the renewable based feedstocks, you actually absorb the CO2. Instead, you pump the oil from underground, meaning that you don't add extra carbons into the environment. That's starting. And then we apply the fermentation process, for example, to get for PLA, for example, to get the lactic acid from the corn or sugarcane. And then we polymerize the lactic acid into the polylactic acid. That's basically the differences on the starting point. But then this is more, we talk about the low carbon footprint kind of part. And then when we talk about to tackle the plastic pollution, or plastic waste, then we talk about end of life solutions. So
mm,
for example, for PLA, we do offer different kind of end of life solutions. For example, now we can enhance the properties of PLA to make it more durable for the reuse, repurpose kind of way. And then also you can mechanically and chemically recycle the PLA, for example. And then on the other hand, when you cannot recycle the PLAs, then you can also compost it into the industrial compost in order to kind of close loop, as we call it, more like organic recycle. So I would say yes, for the bioplastic like PLA, you really tackle the starting more like the low carbon footprint solutions, but also on the end of life of the plastics. Yeah.
Yeah, I think it's really important. I think as designers and people are specifying, architects, everybody, we understand what alternatives are out there.
Mm-hmm.
Sometimes we go to the same supplier and the same supplier does the same thing and gives us the same
Mm-hmm.
stuff.
Indeed.
I think it's really good, and that's what this podcast is all about. It's about education. It's about
Mm-hmm.
raising awareness, obviously case studies and all that kind of thing. But
Yeah.
can you talk about what PLA is? Because if people have kind of like gone, what? So what is PLA? What does it mean? And sort of what is it, if you know what I mean?
Yeah, definitely. So, well, PLA, it's the short word of the or abbreviations of polylactic acid. So it's the bio-based material. Actually, is one of the most well-known and widely used bioplastics now in the world. As I mentioned, so PLA actually it's based or it's made from a renewable resource like sugarcane or corn. To be more specific, the Lumini PLA produced by Total Energy Corbion is made from the ethical farmed sugarcane and actually also known GMO sugarcane as well.
Ah,
So, but that I think that's very important. But also, I think when you really talk about the differences between PLA and the conventional plastics, we talk about the whole process. I think already explained. So we use the sugarcane. Sugarcane actually absorb and store the carbon from the environment instead of pump the carbons from underground, right? So then also we for PLA, it's offered a kind of different type of end of life solutions. And furthermore, I know that, for example, in the building and construction kind of industries, you are really looking for kind of low carbon solutions here, due to the process, due to the feedstock what we are using, compared with the fossil-based conventional plastics, you can reduce 75% of carbon footprint, and I think it's really enormous.
Yeah.
But actually, now I also want to deliver a good news, because the 75% the lower carbon footprint, that's based on the life cycle analysis in 2019. But actually, we're going to release a new life cycle analysis report, which actually we already see the carbon footprint reduction will be even more compared with the conventional plastics. With some of the solutions, we can even achieve the net zero, which is really great. I think I'm also quite excited about this.
Can tell. Exactly.
Yeah.
So what can you use it in? I mean, what's it already used in? I mean, where would we
Mhm.
find it, sort of thing?
Yeah. So basically, I would say the most conventional plastics that you use, you can replace by PLA. So at the moment, PLA already used in a lot of different kind of applications. I think the biggest part is like food serviceware, like food packaging.
Hmm.
I think that's due to the compostabilities of PLA. I think people it has been selected or being used a lot in the food serviceware or single-use plastics, for example, like straws, like cutleries that you normally see in the fast food chain or fast food restaurant. But actually now, as I mentioned, that we really put a lot of effort to try to improve or enhance the property of PLA, now also make PLA more durable as well. So now I think the one of the fastest growing segments for PLA is 3D printing, which I do think that it could be very interesting for many designers, architects on that. And then furthermore, PLA is also quite safe. So actually it's used a lot in kind of hygiene, in the medical packaging, the PPEs. And another big part for PLA currently used is in agriculture, because it's also due to its biodegradability as well as a low carbon footprint. It's used a lot in the mosh films, for example. So as you can see that it's really widely used, and but I also do feel like at the moment PLA is still compared with conventional plastics quite niche. But yeah, that's a kind of challenge, or I think that the target that we actually need to work together.
Yeah, exactly. And and again, if there are designers listening, and I think and artists actually, so I get, there's artists and creatives, but if we've got an idea in our head, or we want to create something, and
Mhm.
yeah, the 3D plastics, there's lots of like sort of bio, alternatives and things like that. It's really nice to have options. Do you know what I mean?
Mhm.
To be able to create something
Yeah.
that's beautiful.
Mhm.
You've got a couple of examples there. I know you showed me before we got. We're gonna put the pictures on the thing, but can you just sort of hold them up? I don't know if you can
Yeah.
just or if you just got
Sure. I
somewhere you
mean,
can't
for
find it.
example, like this one is very beautifully done kind of containers. This
Oh,
one
look.
is actually is made with the 3D printed PLA, so it's really beautiful. Then
So
even
that was. I'm
both,
just going to describe that for people. That was two hands, two in its life size hands holding a bowl, um,
yeah,
and it's lovely actually.
it's
So you can imagine this being used for like planters, soap dishes, all that kind of stuff. So really imagination, and you can
yeah.
print whatever you want. So yeah,
Indeed. There's another one also as from the 3D printed items. So this is actually basically a dragon,
yeah.
which actually you can see that you actually can now use the PLA to make such kind of complex structures.
There's lots of detail on that, isn't there? So it's got
Yeah,
horns, it's got wings, it's got like all the veins on it and stuff. So there's a lot of detail. So if
indeed.
people are wanting to create like nature-based things like leaves or, plants or birds or something, it's like 3D effect on a, in a building or something. I think, that gives them lots of creative options. But
Indeed.
obviously we're using bio-based materials, so we get the benefit of, because some people come to me and go, yeah, but you can't get that in nature. I can't achieve what I want to do. I have to go to plastic. Well, the point of having you on actually is to show that there is an alternative there. And, we as designers need to ask for it. We need to find out where our suppliers are and ask them to go and get it. Look for alternatives. I think it's really important. I will also talk about the circular economy,
Mhm.
how all this fits in. There's many groups out there that I speak to and that our audience are members of, where we're trying to encourage net zero and more sort of circularity in particularly in the design industry and the architecture industry.
Yeah.
Can you maybe explain just how PLA, fits into that? And then maybe also, as a call as well to maybe like urban planners,
Yeah.
to put like end of life solutions somewhere as well, more maybe closer to actually within cities or on the edge of cities or whatever. I don't know what your thoughts are, please.
Yeah, definitely. So I think first I just want to really re-emphasize the importance of the starting, and then as a PLA start from the plant, and which already means that you are not really add extra carbon into the environment, and then you really reduce carbon footprint. So that's really the good starting point. And then as I also mentioned that for PLA, we talk about different kind of circles, closed loop kind of solutions. Now we do have the durable PLA, which actually can be used for the reuse or repurpose kind of
Yeah.
products. And then we also have different type of recyclings. So I mentioned before, PLA can be easily mechanically recycled. Basically, you just simply melt the PLA products or the waste and then spin or kind of create kind of chips or item out from it. So that's one of the recycling routes. And then another part we really call it chemical recycle. I know that at the moment there's a lot of people questioning about chemical recycling because due to the scalabilities, due to the high energy consumptions. But actually for PLA, it's slightly different because actually the chemical recycling technology for PLA, or let's say for Lumini PLA, is what patented by us. It's really the low temperature kind of process. So compare with more than 300-400 degree, this typical chemical recycling kind of technology. I think for the Lumini recycled PLA, the process we use around maybe 100 or even below 100 degrees C. And because the process is different. So for PLA, there's a typical process called hydrolysis. So basically, if you have the certain temperature, you have the moisture levels, the PLA will degrade into CO2, water, and some biomass. So that's actually the kind of idea behind. And then, so we call it advanced chemical recycling. And this is another kind of closed loop solutions. But then the last part is the compostabilities, which we actually talk a lot about it. And that's one of the beauty of PLA is actually with PLA, there's no persistent microplastics. So basically, well, when we talk about degradability of PLA, as I mentioned, it depends on the temperatures, on the moisture levels, on the bacteria. The degradation time could vary, but eventually the PLA will be degraded. I think it will be degraded faster in the industrial compost. We talk about 22 days. Actually, it's even faster than orange peel. But it also can, in the normal nature environment, maybe in the hot area, it will degrade faster, but in the cold ones, it will be slower. But as I said, there's no persistent microplastic left. I think that's really good to mention. And when you talk about yes, I do also feel like at the moment there's a one challenge for PLA or to adopt PLA is for the infrastructures.
Mm.
Because now when we talk about end of life, it can be recycled, it can be composted. But on the other hand, there are not enough recyclers or composters or industrial composters now available. I think one of the really good example or best practice I just want to share is about Italy. So actually in Italy, there are more than 300 industrial composters in the country. So which means actually Italy also really push a lot on the compostability or compostable solutions. Then I think this is the time to call for actions. I do feel like architects, the designers, I do see that you play a very important role in order to advance, to accelerate this kind of process in order to establish the infrastructures in order to create this kind of ecosystem. Yeah.
Yeah, and it's true, isn't it? Like, so town planners, and like you say, architects, and if we're able to specify more local recycling
Yeah.
facilities that are maybe also designed nice, rather than being these like horrible, industrial looking, scary, concretey, yucky things,
Yeah.
to put it very, technically.
Indeed.
But ultimately, they're a blot on the landscape. But how lovely to be able to create something that's also visually interesting, that then
Yeah.
is a composting facility that, that's actually enhancing. So it's putting life back in, and it feels like it's doing what it's supposed to do, by changing and absorbing, and making something into something else, sort of thing that we can then grow again. I love that.
Yeah.
Um,
Yeah. Definitely.
I spoke to Lambda, and I published the podcast, and they're a new innovation, sort of based on a sheep wool
Hmm.
product for insulation, and obviously
Yeah.
it's obviously biodegradable and all that good stuff as well.
Yeah.
They're just on the point of scaling. They're just on the point of need looking for investors and all that kind of thing. But
Mhm.
you mentioned that there's a couple of challenges there, that you're just on that point. You're bigger, you're in lots of places. But can you
Mhm.
can you explain how big PLA is scaling?
Mhm.
Where people can get hold of it maybe as well. So if there is a designer listening, you know,
Yeah. Yeah.
how do they approach you? How do they get hold of your stuff?
Yeah, definitely. Actually, in my views, a successful product, you need to have like 3 points that you need to check. The first, the performance. I think we also quickly touch base on that already. The
Yeah,
second is sustainability and or circular solutions. I think we also talk about that as well. The third one, what I do feel like is very important, is the accessibilities. What I mean is, okay, the product need to be globally available and also it need to be affordable as well.
yeah,
So then if we go back to the scalabilities of PLA, so when we talk about the global PLA production capacity now set to triple by 2028 compared to the 2023. So then when you talk about really the Total Energy Corbions, one of the leading PL producers, we were founded in the 2017. So actually in the past 8 years, we grow from zero. Now we have 75 kilotons of the capacity in Thailand. So I would say it's not really as big compared to the conventional plastics, but on the other hand, actually it's big enough. So we are not a kind of startups, and then we are commercialized. We can supply globally, the global customers as well. And then I think another point I also want to highlight that we do have a lot of adoptions with different kind of brand owners. For example, with Danone, we have the yogurt cup made with Lumini PLA, and we work with Mars for the packaging for this kind of candies. And then there's or for Chanel, we also have this kind of cosmetic packaging, the jars made with PLA as well. So actually, there's a lot of good practices that we actually can share. So I do encourage the audience to check our website to get more inspirations as well. Yeah.
yeah. It's great because it's non-toxic as well, isn't it? Because you mentioned, food. So obviously, food contact. Yeah,
Yeah, yeah. I think another point I want to add on more on the safety side. I think when we talk PLA or lactic acid or polylactic acid, it sounds not really familiar to people. But on the other hand, actually everybody produce lactic acid. Maybe that's kind of could be a bit surprise to many of the audience, but actually our muscle produce lactic acid. So it's not really new to us. And then, as you mentioned as well, so the Lumini POA actually is food contact approved, so it's used already a lot in the in the yeah in the food serviceware or in the food packaging. But then I do not recommend you to eat it. It's not a food. So
Yeah, not a good idea. Avoid that
yeah,
one. Yeah.
indeed.
Obviously architects are, listening as well. So how can architects and designers use it? What would you suggest? How, have got any ideas?
Yeah. So as I mentioned, so PLA actually it can replace most conventional plastics,
Mhm.
and I think to offer similar performance as well. So now, if I can thinking about, we can kind of group into the different groups. For example, I know that in the furniture there are a lot of packaging materials.
Yeah.
So these definitely is already mature. You can buy the films based on PLA. You can buy the other wraps based on PLA there. So you can imagine that if we can replace all the packaging material for furnitures
Yeah.
to the PLA, you can really reduce significant carbon footprint, and then also to mitigate the plastic pollution issues. That's the first one. And the second one, I also do feel like, for example, like exhibitions, like conferences, there's a lot of materials or the building material they only use once or twice, and then they just simply burn it or, I don't know, landfill it. But I
Mm.
do see that PLA can play a very important role here. Try to make either the circular solutions or to really offer kind of sustainable alternative there as well. I think the third part, which I feel is more linked with interior elements, like we do already have this compression molded coffee tables with PLA. Actually, it's already been launched in Milan Design Week last year.
Okay.
And then we also do have the 3D printed lamps. Basically all the decorative objects you can actually use 3D printed PLA to achieve. The last part, which actually is quite big, is the textile. Then you talk about upholsteries, you talk about carpet. So we do have the PLA-based fibers, which actually can be used to make these kind of textile or textile-based applications as well. Yeah.
Okay.
Mhm.
And then I suppose that maybe the big challenge as well is in construction. That's a massive, massive polluter. And
Yeah.
obviously if we can use timber, then that's great. And we've had people on about talking about timber. But how do you
Mhm.
see, PLA being able to be utilized in.
Yeah. So I think for the constructions, really, to be honest, I think PLA at the moment is not really widely used in the construction side. I think one of the good practice I can share is the cavity wall.
Mhm.
So actually now we have a project ongoing, use the PLA to replace the formable PLA to replace the traditional foam and to feed into the cavity wall in order to really create a pretty good insulation performance there. I think this is one of the, I would say, close to commercialized case that I can share. But on the other hand, I also do see that there's some good potentials. For example, any kind of temporary structures and the model, the prototypes that you do when you want before you build the beautiful buildings. You do need to make it the small models. I think all this, it's good that you can think about to use PLA for. And then also because of the biodegradability of PLAs, I think all this kind of form works and normally use because PLA is also recyclable. So you can really thinking about, to reuse, to recycle the formwork based on PLA. Even there are some pieces left into the environment. So we don't need to worry about the microplastic issues because as I mentioned, PLA eventually not leave any kind of persistent microplastics behind. I think another part, I think I already mentioned insulations. That's actually is already kind of almost commercialized. I do feel like this three part could be something can explore together with the some potentially partners for construction area. Yes.
Yeah. So are you
Mhm.
just, for asking the sort of next couple of questions, but are you
Mhm.
looking for people to kind of reach out to you? So if there's like an architecture company or, maybe there's a manufacturer here, or people who are, working in this kind of space. Are you inviting people to kind of reach out and collaborate and help?
Definitely. So for us, we do think that we cannot make things happen only by ourselves. We do highly value the collaboration, the partnership, and then I think for building and constructions, we don't really have that many experience, that many knowledge. But on the other hand, we have a lot of experience, knowledge about PLA, about the bioplastics, about end-of-life solutions. So I do see that this could be a kind of win-win case here.
Yeah.
Mhm.
Amazing. So, kind of in an ideal world, what would you like to see in like 10 years' time? How would you, I would like to see plastics gone completely personally. But
Yeah.
how would you like to see?
Well, I think in 10 years, let's say it's long, but it's not really long. I think it's just gonna happen. So and the most I think the most important thing I do would like to see the global shiftings to the circular materials.
Mm,
Basically, when you we I really would like to see the dramatic reduce on the plastic pollutions, and then also the I do would like to see there's more kind of adoptions on the sustainable solutions, the bioplastic, recycled plastics as well, and then also because at the moment I do really feel even PLA used in quite different applications, but people still see as a kind of niche. But then I do would like to see that it become a mainstream alternative to the
yeah.
conventional plastics. Then when we talk about to really improve the infrastructures, to improve the recyclings, composting infrastructures, and then yes, and of course the importance of the collaborations across the industries and really rethink about material you are using, take the consideration of the end of life solution as well, and then also try to build this kind of ecosystems. I do feel like there's a lot of challenges, but on the other hand, there's a lot of things that we can actually do together.
Yeah, absolutely. And
Mhm.
collaboration is key, isn't it, really? The
Yeah,
more we talk, the more we learn, the more we're
yeah,
armed with the facts rather than, oh, I kind of hearsay or, being, a lot of greenwashing as well that goes on.
indeed.
How
Yeah.
how do you think we can accelerate that? How can we make this change happen faster? Apart
Um,
from, well, there's lots of
Well,
things we could think
I
of.
think the most, yeah, indeed. I think one of the most important thing is instead of talking, just take the actions. Because I do feel like when I talk with many brand owners, they say yes, and PLA is good, or bioplastic in general is good, but it's not perfect. But come on, if you really compare with conventional plastics, it's really a big step forward. Maybe just take the actions and then start doing things. And I think 2030 is not far away. So we all have the target to achieve. I think this is a very important thing. But of course, I also do see that all the stakeholders really play in the value chain play a very important role there as well in order to make sure that the adoption is happening. But another very important piece I think we haven't really have time to talk about is the policy frameworks.
Yeah.
Because in order to really implement, I do see that the really support needed from the local government, from central government, and from the policymaker as well. While in Total Energy Corbion, we do have people really try to talk with the policymakers and then to really like try to educate or advocate the key stakeholders in that as well. So I think with all these kind of elements work together, I'm pretty sure that we can accelerate the change. Yeah.
Yeah, exactly. And and it's great, as you say, it's great talking about it, it's great learning about it, but actually, doing the action, really taking a chance as well, taking a
Yeah.
risk.
Yeah.
You got to take a punt, like we all do, I say when we take a punt when we fall in love. We take a punt when we
Indeed.
pick up when we know if we have an animal or a pet or something, we're like, we don't know if it's a manic one or a whatever, we still love it and get on with it. So
Yeah.
yeah, I think we should all take a punt on PLA. There we go. um, so my final question, which I ask everybody who comes on the
Mm-hmm.
podcast,
Mm-hmm.
is a magic question.
Yeah.
If you could paint the world with a
Hmm.
magic brush of biophilia, what would it look like?
Yeah, I really think about that. I do feel like a world where the materials is harmony with the nature. That's really the dream for me, and I do really feel myself as a promoter to that. And then I do also looking for the partners to work with it. So yeah, let's try to make it happen.
Thank you for listening to the Journal of Biophilic Design podcast.